Greetings to all the students. Today we're going to learn about pressure and its applications. Let me quickly take you through the main topics under this chapter. We have thrust and pressure, pressure due to solid, pressure due to fluid, body in the fluid, and Pascal's law and applications. However, in today's session, we are going to discuss about two topics: pressure due to solid, thrust, and pressure. Before we look into the definition of what is meant by thrust, let me give you few examples. If you take any objects and place them on any surface, these objects will exert force due to the weight of the object, and then this force, as you could see, act normally or perpendicular to the surface in contact. Therefore, how do we define thrust? So in short, we define thrust as the force acting perpendicular to any surface area that is in contact with the object. You got it? Now, can you write down the SI and CGS units of thrust? Let me give you a hint. Thrust is also a force. Okay, units. SI unit is Newton. In short, we write capital letter N. CGS unit is dyne, and in short, we write DYN, dyne. Okay, going to the next topic, we have pressure. To understand pressure, let us consider this example. Suppose I give Nultum 300 to a class of 30 students. How do you find the money an individual student would get? How do you find? The money an individual student would get is found by dividing the total amount by number of students. Thus, you get Nultum 30 per student. So, in similar way, to find pressure, we consider total amount of force, and that total amount of force is divided by the area. Therefore, pressure is defined as the thrust or a force per unit area. So formula, it's very clear from the definition. Formula for pressure is force or thrust divided by the area. P is equal to F over A. Units of pressure. SI unit is Newton per meter squared, or in short, we also write it as Pascal, PA. And CGS unit is dyne per centimeter. We have here per meter square or centimeter square because area is in denominator. Other units include bar, millibar, and ATM. 1 bar is equal to 10 raised to 5 Pascal. Let's look at the second part, pressure due to solid. What is it? Pressure due to solid. Solids, due to their own weight, exert force and pressure whenever they are placed on any surface. Thus, the magnitude of pressure due to this solid depends on two factors. How many factors? Two factors. They are, number one, magnitude of force, and number two, contact area. To understand how these two factors affect the pressure exerted by solid, let us consider few examples. First, you're given with these three objects E, B and C. It's very clear that these objects have different weight, thus they will exert different force, right? Alright, from this diagram, which object do you think will exert the greatest force? What is your conclusion about the pressure? Going to the next example, here there are two footwears X and Y. Which footwear have the smaller or sharper contact area, X or Y? Which one would be painful should they step on you? You got the answer? Okay then, let's look at how these two factors affect the pressure. Thus, from all of these examples, our conclusion is if the magnitude of the force exerted on the surface is greater, the pressure will also be greater. 2. Smaller the surface area, the pressure exerted is greater. Now let us look at some more examples. Pressure exerted by iron hammer is greater than the wooden hammer of same size because of greater thrust by iron hammer. Sharp knives exert greater pressure because of smaller area even with small applied force than the blunt knives. Trucks have bigger wheels so as to decrease the pressure on the ground. Building foundations are made broad to increase the contact area for decreasing the pressure so that it can withstand the huge load of a building. Owing to their larger area of hooves, camels can walk easily on the sand than donkeys. You got it? So in the next lesson, we're going to discuss about pressure due to fluid, body in fluid, Pascal's law and applications. Till then, bye bye.